project and walk through it so everybody understands how that works. So for many of the teams that are doing Android stuff, that will benefit you so you understand how Firebase this month works with Android.
Did you do that with Java classes too? I'm curious.
Huh?
Did you do that with Java classes?
I did that in 300, not 200. It wouldn't be meaningful to them because they're coming from not an IDE background and never seen Java background. So
That's a good question. Why am I on team 3.5?
Oh, why is there a 3.5 team?
Yeah.
well, I didn't figure that was an important team. So yeah, I thought that was kind of self-explanatory. I think I had already gone through and made the teams like done sorting based on the numbers, and then I decided, oh, I'm going to make another team out of this. So
yeah, and they're kind of both joined later on that team.
Yeah, so then once I changed it to 3.5, then you sorted in my database, my Excel sheet correctly. I mean, I could have made it 3.1 or 3.9 if that would have. I figured.
Or at least half of it.
No, I wouldn't even go that far.
So we expect half of a project?
we expect a double project with a quarter of the talent. Yeah, that's it. All right, so let me just show this here quickly. Then we'll look at the Android stuff. So in our thread example from last time, couple things to clarify. So up here we created our struct, right? So I called this guy a client thread type. Here are the things that's going to store. This dude here is a variable of that guy type. So I can create multiple struct variables on the fly like this if I want. You could also create them the way we were creating them last time, where we were creating a struct, then the name of the variable, and then you can just use it. But this is like a convenient way of creating variable names. So I already have something called CT1 here. All right, so I should already have a variable called CT1. If I come down here to main, notice I'm just using that variable directly. So CT1's already in scope. I'm setting his socket ID, even though this actually isn't a socket thing yet. I'm just using this to do the counting stuff. I'm setting this equal to the address of X, which is just an int. And then I'm setting the connected clients equal to my array here. Then when I go to start up the thread, I'm going to pass, this is the inc_x thread. This is the one that's taking the address to our struct, if you remember from last time. So we decided we needed to pass it more than one parameter. So we were going to wrap those guys inside of a struct and then ship them into that function. So when I create my thread for inc_x, I pass it, its one variable is the address of my struct, CT1. Great. All right, so that was all. I mean, all that actually was working okay last time. Where we were dying is in here when we were taking our struct back to, I don't even know why, but I had the star on that side of it. Yeah, so that's not even syntax that's usable. So I'm going to create a variable that's of struct client thread type pointer. And this guy's going to hold the void pointer that's coming in there. So this is effectively typecasting it to that struct type. All right. And now this was the other kicker. See, technically, this guy, it's a double pointer because the struct that I have here is a client thread pointer. And the value that's inside of it, socket ID, is a int pointer. So we have a pointer that points to another pointer. So you can address this by saying ** dot socket ID, like that. It's a pointer to a pointer. The convenient syntax in C for this is that. So instead of dot notation, you use an arrow, and this is the double pointer syntax. This is a pointer to a pointer. So this presumes that CT holds a memory address, and that this guy holds a memory address. And this will give you the value at socket ID. Okay? And then all this other stuff is the same as it was before. I'm just adding stuff to that int. So let me GCC, probably have it in here with the pthread thing. And there's my X counted up to 100 there. All right, so the biggest thing I did that was dumb was I was saying struct, I'm guessing that's what I was thinking, struct pointer, this, when actually it's a struct client thread type pointer. The struct is just needed to kind of flag this guy as being of type struct, so it handled the compiler handled it correctly. All right, so in any case, that gives us the structure that we would now need to go and insert this into our chat server, and we'll look at that on Monday. We'll do it in here. I'm not going to give homework over the weekend because of the hackathon, but in any case, that was the struct problem, and I was rushing at the end of class last time to try to give an assignment, but you know, that didn't happen. All right, questions about that? Okay, so let's look at, I'm going to look at that guy. Close this. We do have a cool project going on in 548 right now. We're writing a ARM assembler in Android. So it accepts low-level ARM instructions as an assembler, and you can view memory, you can view the registers. It's pretty slick. And then we added Firebase support to it too. Yeah, so I also covered the Android stuff in 548. So if you have one of the grad students in your group, so that's Edwin, Romana, Shika, Monique.
Got 3 of them.
Three of them. They're bright. Which 3 do you have?
Not the first, but the next
Oh,
3.
they're the good ones.
Oh, good.
Yeah. Then Jonathan Shoddy. Is it Shoddy? Shoddy. Yeah. He's bright, but he's less experienced with programming, but he'll pick up stuff pretty quickly. He's working on his master's degree in computer science.
I know, that's like the same look I got when I got.
Yeah, I think mathematics.
I just didn't expect an RD. I know, right?
Yeah, this is he's in his first 2 classes right now. In that. And then of course, Van's in that class too. He's taking a grad class as an undergrad. So bring your Vietnamese to English dictionary with you. Van's really smart. Just don't have a clue what he's saying.
Yeah.
Just be ready for him to take a good 5-hour break or a break. Just disappear for a while.
Like did he do that last time?
Yeah.
Did he really?
He was in my group last time. He's like, I'm leaving. And he left.
Really?
Yeah.
Oh no! Tell me if that happens. I wonder if there was like an emergency or something. That doesn't seem in character for him.
That's not cool.
Retroactive penalty assignment. Let's go.
Oh, I will. Okay, so let's look at the first thing I want to view. So this Android starter application here, I'm just going to minimize some of this stuff so we can see more of the code. All right, so this starter application, I've actually written things a couple different ways. So if you hadn't recently looked at if you had previously looked at the starter thing before, let's say yesterday, it's been updated since then on GitHub. So the goal here is to store a couple of different types of objects inside of Firebase. All right, so Firebase is a real-time database. The biggest perk of Firebase, as I see it, is the fact that if we look at an older model, and this is actually related to our chat server stuff. Well, so if we just operate this off of our chat server for a second, right now messages are getting, stored locally and just well, not even stored them, we're just rebroadcasting them. But let's assume every single time one of our users chatted, sent a message, we stored it in a database somewhere. Okay? And then what happened here is all of the other child threads, they would maybe check that database every 5 seconds, let's say, for new messages, just using an exaggerated old school kind of example. And at that point, if there's no new messages for an hour, or let's say for a minute, the client has checked back to the server, the database, a whole bunch of times unnecessarily, right? So it causes a network hog, blah, 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 all this other stuff. What Firebase does is it allows a client to set up a listener with it and say, I am interested in hearing back from you whenever something that I'm interested in changes. So it can say, I want to know when this particular, let's call it table in the database, changes. And then what Firebase will do is it will contact you when that change happens so that you don't have to contact him. All right, so it makes it more of a push approach as opposed to a pull approach, which allows your applications to be much more responsive. You'll get updates immediately, that kind of stuff. So actually writing, one of the things we're looking at in 450 here is, kind of how difficult a chat server is to write, even though it seems like such a primitive type thing, right? So writing a chat server for like a mobile application or something like that with Firebase actually is quite easy because of the way Firebase works. You just tell each client to say, yeah, just let me know when you have a new message. And then all the individual clients have to do is when somebody types something, just write it to the database. The database handles the rest. They broadcast it to everybody else. So it actually makes it pretty simple. Okay, so the goal here is we have a user object here. And a user is going to keep track of 4 pieces of information. They're going to keep track of their first name, their last name, their age, and then they're also going to have an array list of message objects. All right, so this is kind of showing you how do I store some non-identical types of values in Firebase, as well as how do I store a collection type in Firebase. Okay, now up to this point, this guy just looks like a plain Jane Java object, right? Nothing special about it. All right. The one kicker here, the one thing that Firebase does require is that your fields are public. They have to be public. In fact, the program will crash if you try to make even one of them private. All right. So your fields have to be public because the way it builds your object, and I'll explain this when we get to that part of it, is through those public variables. All right. It used to be that it sent stuff up to Firebase through a hash map and then read in from Firebase through public variables. Now it does both sides through public variables, which I suppose makes sense, but it also makes their documentation out of date in some of the examples. So all your fields have to be public. That's the one thing. Another thing, you have to provide a no argument constructor. You can do stuff in here if you want, but it probably wouldn't make sense to do things in here. But you have to have a constructor that takes no parameters. Okay, this is a portion, I'll point out where this is used, but this particular guy is used in a very specific spot when you're reading stuff in from Firebase, so it knows how to build your objects. Okay, kind of at the high level, what it does is when I read something down from Firebase, what the API does is it creates a blank, in this case, user object, and then sets the public fields to the 4 or 5 4 values here. Does that make sense? As opposed to calling my reasonable constructor that takes in, some variables and sets them locally like you would usually do. All right, that makes some sense? This is how the reading from Firebase would end up working. So this guy's required. This guy's not. You don't have to have a constructor that works more traditionally. Nothing keeps you as a programmer from going ahead and creating a user object, user u equals new user, and then saying u.fname is equal to Mike, u.lname is equal to Littman, so on and so forth. Nothing keeps you from doing that. That just isn't real great object-oriented programming practice. All right, so you have to have the no argument constructor. That's it. These other ones are just things that I happen to be using in mine. Plus, this is the way as human programmers we like to build objects by passing them into the constructor rather than setting the fields separately. Otherwise, we might as well be using structs, right? That's effectively how structs work is you build a struct and then you set the 3 or 4 values of the struct separately. You don't have the idea of a constructor. So, I guess whatever. All right, so this is one of the kinds of animals we want to store in Firebase. Similarly, we have another animal we want to store in Firebase called a message. Message is going to have a title and a body. Here's your public constructor here. Here's my human constructor. And then I just have a display function for testing purposes. So the only things that are required by Firebase here are those. Public fields and a no argument constructor. Okay? Other than that, your class can be a normal plain Jane Java class. All right, and then notice back here in user, my array list is a collection of messages. And inside of my version of the constructor here, I pass in the first name, last name, and age, set those fields, and then I go ahead and I build a new array list of messages and fill it up with 10 sample messages. Okay? So any questions on the user or the message object in this example? Pretty good sense? Okay. So now let's go to the point where we actually make Firebase work with this guy. All right, so one of the nice things with Android Studio, as opposed to Xcode, is with Xcode, in order to get Firebase working, you had to use CocoaPods to bring down the Firebase API and then configure your project with a couple things. It's not bad, but it's probably 6 or 7 lines of code or something to get it connected to just the real-time database. With Firebase, since it's a Google product now, they bought it, I think, 2 years ago or 3 years ago. Now they've integrated, well, so you have Android, you have Android Studio, and you have Firebase, all Google things. So if you go up to Tools here, you have an icon here that already says Firebase. So you click Firebase on this guy, it'll open up the Firebase Assistant. So if you have a brand new, fresh project that you've never incorporated Firebase into, it will look like this. Now this is kind of important though, because this is the stuff that you will have to do on your brand new project when you first create it for your application. You won't be able to just bring down my project here and then use that as your exact starting point, because then you'll be writing to my database, which is fine. I don't care. I just made it as a sample database, but you're going to have each other writing conflicting stuff to the database. So actually, let's see if it'll let me show it to you from here. So this is all the stuff that Firebase can do. So we have analytics, cloud messaging, which is like push notifications. It supports authentication, but remember, for the hackathon, apps should not have authentication. You should fake it. And there's an important part of this that's going to be required for faking it, so I'll bring that up to pay extra attention when we get to that. It allows you to store images and do some other stuff. The thing that we're going to be most interested in, though, is the real-time database. So click on real-time database. It says the save and retrieve data thing. That's what we want to be able to do. All right, so, oh, that's interesting. Well, I guess I'll be able to go through the process. Now, I'm going to go, is this my Android Firebase starter? Okay. So I'm going to say connect to Firebase. Parse the Android application. That seems good. Can I reload Gradle here? Let me just reopen this project. Very interesting. I'm just going to create a new project then real quick. That's fine. I'll create a blank project here. I'll show you how to connect this guy to Firebase and the various setup stuff you need to do, and then I'll bounce back to the other one for the code. I was messing with this last night, so I might have broken something. Okay, so again, we'll go up to Tools, go up to Firebase. I'll click on real-time database, save and retrieve, connect to Firebase. It's going to start trying to connect to Firebase. It's logged in. This is a different account I use with Gmail because my other account has all of the Firebase Firebase databases it'll let me create on there. So notice here that I already have some things on here. I did try. Let me. Sign out and sign back in. Try signing into my normal account here. Yeah, here is the hackathon sample. So you can create a brand new Firebase project up here and give it a name and then create it. Or you can connect it to an existing one. So I'll reconnect it to an existing one. So I'll go to hackathon sample, connect to Firebase. Okay, so notice this guy now says it's connected. Okay, so you would have either gone to Firebase or you would have just created a brand new one here, and then it would say connected. Next thing we need to do is we need to bring in those API libraries to your Android Studio project. So just click add the real-time database to your app. It's going to say, hey, these are the couple of changes I'm making to Gradle. Just say, yeah, I'm cool with that. Hit accept, and it will download the right stuff and configure your project for working with Android Studio. You are working with Firebase rather. So you get another green check mark here. All right, then once you get down here, here you can read about authentication if you want to also have authentication. You can configure your rules for public access. I'm not even going to click on that because I'm going to show you how to do that otherwise. So really everything we've done everything we need to do to make our project connected to Firebase now. All right, so now I'm going to go ahead to go to the Firebase website. I think it's, yeah, here's the hackathon sample. I'm going to actually just delete all that right now. And then I'm going to click away from this, then I'll click back onto it. Good. So when you first create a project, when you come to Firebase, you'll let me go to Firebase here. You'll go to Firebase, which is console.firebase.google.com, or you could just go to firebase.google.com and then click go to console. That'll take you to this screen. Click on, in my case, the thing I created was hackathon sample, so I'll click on that. And then the thing we're interested in here is database. So click on database. If you don't see it, click on develop, which should open that guy up, then click on database. And we're doing real-time database here, so go ahead and hit get started. All right, so it will do this for you. So by default, if you create something, it starts up in locked mode, which means that you better have authentication, otherwise you won't be able to read and write to and from your database. All right, so check start in test mode, which means that anybody can read and write, assuming they have the reference to your database. All right, so that's what you'll want to do for the hackathon, is make sure you're in test mode so that you don't have to implement authentication. So then just click enable, and now I have my blank database. Okay, so now I'm going to go back. I'm going to close this project. I'm going to open up this one, okay? Because I think this one still works. Just there must have been something I messed with Gradle for the other thing. All right, so we've already looked at user and messages, and this guy, although this will be interesting because I did disconnect it, didn't I? So we might have to build it, the other one. Yeah, it's connected. All right, so, oh, I know what the problem was. The problem was the project we worked on last night in the other class where we integrated Firebase into it, I logged into my Thinkful account. This project's connected to my AwesomeFat Gmail account. Android Studio must have saw I was logged into Thinkful, got freaked out here because it was looking for a database that previously was connected but was on my other account. And it didn't handle that very well, it seems like. All right, but now I've logged back into the account that this guy's hooked to, so he seems green checkmarky happy. All right, so we've looked at our two objects here. So now we're going to go to our message. I'm sorry, not that guy. I'm going to go to main activity. I'll hide this. And I'll hide this. I'm going to scroll up to the top, and the first thing we're going to look at is writing data to the database. All right, so notice some things are imported up here, but as soon as you write these couple of lines, it'll import those guys for you. So we're going to need a pointer to our actual database. So we'll create a Firebase database called database, and this guy's going to be equal to Firebase database.getInstance. This will give us a pointer to the Firebase database that we have connected to. Okay, if you're on iOS, you have to like put in your unique ID for your database, and then it will do effectively the same thing. All right, now I'm actually not even using this guy anymore. So I'm going to take that out for right now. I am using it, but for some, I don't actually use the code. I'll leave it in there for right now so it doesn't give the error because I changed this up last night. This is giving me direct references into my database to particular, we could think of it as tables if you have a background in relational databases. I like thinking of it as almost folders when you deal with a real-time database like Firebase. So I'm going to have a folder in my database called messages if I write to it, and I'll have a folder in there called users, again, if I write to it. All right. So these guys just give me pointers into there. So if I say database.getReference, it's starting with my base database, which is this guy we see right here. And then if I say give me a reference to a folder called messages, anything I would write to would show up in messages here with more stuff inside of it. And we'll see that show up here in a few minutes. All right, so these guys just give me pointers to those couple of folders in there. You can design yours to work however you want. You don't have to go and write them in Firebase first. You just decide what your structure is going to look like here programmatically. All right, I'm going to skip this part for a second and just go down here to where we're actually writing stuff. Okay, now all I'm actually writing to my database is a bunch of user data. And the user data then in turn creates messages inside of it. Before I actually had it creating a bunch of messages and a bunch of users, and that was really kind of showing the identical example. So now I'm having it create a bunch of users. Inside of that user, we'll have first name, last name, age, and then we're going to have a list of messages, an array list of messages with 10 messages in it. All right, so you'll see how that works. So I'm going to create 10 users here. So normal little for loop. Now, what ends up happening here, this little guy right here, this dot push, what that will do is it will generate a unique ID for, effectively, it'll put inside the users folder a folder with a random looking number in it that is a unique folder in there. Okay? So I'm saying start off with my reference to my user folder, push onto that a generic folder that is unique to any other folder that might be in there. And then give me that reference. So temp user will point to the users folder and then this unique folder inside of there where I want to store my stuff. Okay? Then I'll go ahead and I'll create a brand new user object, just like we create any Java object. So first name is first name plus I, so this will be first name 0, last name 0, and then I randomize the age between, looks like 7 and 21. 7 and 21 will be what his age is, just using a random number generator. So this will create me a user, and then I'll tell my reference there to go ahead and set the value, in this case, in the users folder, in the unique folder name to this user object. And it will write it there for me. All right, because what it's doing is it's going to this user object, and it's going to write every one of the public fields. So it'll write the first name, because that's a public field, the last name, the age, and then it also will write an array list. Now you do need to make sure that you write your code in terms of the types that Firebase supports. Okay, so it supports basically all the primitive types, and it supports lists. Array lists work the best because you can write a linked list there, but when it comes back out, it's going to come out as an array list. So any way you cut it, you're going to have to cast it back to an array list. So if you just use an array list for any of your dynamic collections of things, it'll just work. Okay? So I'm storing 4 different kinds of values in there. Now you'll see how Firebase handles array lists by default here in a minute. Okay, so back out in here. When I say set the value at this place in Firebase equal to this object, it saves to Firebase. And I'm creating 10 of these guys. All right, so just real quick here, notice that there's nothing in here right now, right? I'll go ahead and run my program. And forget about the stuff above there. That's for reading stuff back out, which I am doing simultaneously, but you'll see how it works in a second. All right, I think that's my sample application. And now you see it is filled up with 10 users. So I have a users folder. Inside of the user folder, I have, this is the result of the dot push. Crazy folder name, another crazy folder name, another crazy folder name. All right, so it gave me a reference to a unique folder so I can differentiate these users from each other. Now, if I go inside of this folder, I see that I have first name 0, last name 0, age 9. You also see I have a collection of messages in here. So this was my public field that was of type array list. So when I expand that, I have bucket 0 is body 0, title 0. Bucket 1 was body 1, title 1, because that's what I filled those objects up with. Does that make sense? All right, so I get my whole array list in there as well. All right, so this is a folder that contains users, that contains unique identifiers for those users, and then contains 3 public variables, and 4 public variables, 2 strings, an int, and an array list. And that array list happens to hold other objects. Okay, so now reading from our database, just for right now, I'm going to go ahead and I'm going to comment out this. That way I won't create more stuff. Okay, and we're going to go up top and we're going to look at the 2 different ways. Well, they're actually the same way. One, they do the exact same thing, just one looks scarier than the other. Something along those lines. All right, so I'm going to look at the second one here first. This is my user reference because the first one I'm not actually using. I just showed you an example of how it could work. So what I'm doing here is I'm taking my user reference, and this is my reference into the database that points to my user folder. Okay, and I'm adding a value event listener to that. So I'm taking that reference, I'm telling Firebase, I am interested in knowing when changes happen inside the user folder. All right, so I'm going to add an event listener to add a value event listener to this. And that guy is going to be equal to a new value event listener. Now, for those of you who had 470, when I pass a function or something like that to another function, what's that called? It is a lambda. Remember closures? Yeah, so a lambda is a unnamed function. If I pass that lambda into something else, I'm using a closure. All right, so this is effectively a closure. If you're in JavaScript, it would be called like a callback, something like that. So I'm creating a new value event listener on the fly here. Now, a value event listener is actually an interface. So it's an interface that just dictates that I must write a function named that, and I also must implement a function named that. So that interface says you have to write these 2 functions. Okay? So I've gone ahead and I've created a brand new value event listener here. So I've created a generic value event listener, and on the fly went ahead and implemented my 2 functions. All right? As opposed to what I did up here, which looks way less scary, right? Okay, down here, this has all sorts of curly braces and looking, it looks more intimidating. I'm doing the exact same thing up here. But instead of generating a brand new value event listener, I am creating an instance of my message listener. And my message listener is a class that I wrote here so it's a class message listener that implements a value event listener, and there's me writing those 2 functions. Same exact stuff. I've just encapsulated it inside of my message listener object, which happens to implement a value event listener. Therefore, out here, I can add a value event listener to message ref by just passing it the instance of message list. or message listener. Make sense? All right. So choose your poison. I think better programming practice is something like this. But what I find interesting is you will very often find examples that look like this. Why do you think that is? This is more of a question for any of you who've kind of dealt with Firebase before and seen how these things work. Why do you think that a lot of the documentation show you the example like this, that's kind of the more intimidating looking, scary example, versus this, where I've created my own class with that stuff inside of it?
Sometimes in my listener,
Well, just because you're copy and pasting doesn't mean it doesn't look more intimidating. If you're somebody who isn't used to looking at code, this is, at a glance, this might be like, what the heck is going on there, right? You remember those days?
I actually always have.
Okay, yeah. So where this, that looks a lot cleaner, even though you assume there's some magic going on behind the scenes, right? That's what you're gonna say?
Sometimes in my listener, I want to access stuff that's like in that only available in the class that I'm already in.
That's a good point, is that you might want to have direct access to something that's in that class, but you don't have access to this. So you have to hack this if you want to have access to this. Let me show that to you real quick, just, so I can go ahead and I can say I want a main activity, we'll call this guy this stand-in. We're going to set him equal to this. So I can use this stand-in now, but I can't use this inside of here because this is out of scope. Because inside of here, this points to the instance of this guy. This stand-in is the instance of my main activity that I just created right here. So that's kind of the hack to get access to the main activity in there. But I think that actually wasn't what I was going to say, but that is a good point. That if you need convenient access to those things, you can have them. I mean, you could certainly pass them as parameters to this if you needed them, but I think your point is a good one. Probably, I think the more global point, and I think it's even related to that, is usually when you do these listeners, the logic you're putting in here is usually pretty simple logic. You're just kind of doing just one or two little things. Now you have to kind of weigh that against having extra classes in your project and whether or not that kind of muddies your water when you're trying to go and find stuff. Okay, if only this class cares about accessing that Firebase database, and the listener that I'm using is very unique to this class itself instead of something that I can use in 20 different classes, probably makes sense just to write it on the fly like this so I can keep it all compartmentalized with just this object. But at the end of the day, the code's the same, right? I'm just hiding it in the second example. Okay, so we'll look at this guy here since the code's the same. So for a user reference, I'm going to add an event listener, which effectively says, I want to know when stuff changes in the user folder. And initially, when you first launch the application, it'll give you a dump of what's in the user folder. So you have access to that stuff. All right, so this function is the function that gets called whenever data has changed, or when you, like I said, when you first launch the application, when this listener first sets up, the data is immediately thought to have changed. So you get the initial data. So maybe you want to use it to fill up an array of user objects, something like that. Okay, so the first thing I print out here, though, is I get this thing called a data snapshot. And this effectively is a collection of, well, it's JSON. So in our case here, it's going to be a collection of JSON objects, where each object is one of those little unique folders. Okay, so users is a collection that holds a bunch of folders. Each of those folders holds a JSON object, because each of those folders holds the information about a user. Okay, so this will print out the JSON. Then if I want to get it back into an object, so this is the magic on the other side, I can go through all the children in that snapshot, because each of those children will be that little unique file name. Okay, for each one, I'm going to go ahead and create a new user, and I'll say child get his value. So I'm saying unique folder name, tell me what lives inside of you. And that will be this stuff. Make sense? This is the child. So it's the child of the user folder. This is the child. This is the value of that child. All right. So I'm saying I want to get the value of that child, and I'm telling it that guy is a user class. Turn it back into one of those for me. So I'm creating a variable here called value, capable of holding a user. This guy is going to catch the result of this. Now, what's happening in that line that I've highlighted there is it's using the default constructor, this guy right here, to create a blank user object. Okay? That's why we have to have this empty constructor. Then it's setting that guy's first name to the first name, the public field first name. So let's say the user it created was called temp. Temp.fname is equal to whatever the fname thing from JSON was. Temp.lname is equal to whatever the lname entry in the JSON was, so on and so forth. All right? And then we're also relying on it to do the magic with array lists because it does support them. All right? So it's actually going to do the magic of putting that array list back into message objects and then throw it back into our list here. So there's my user, and I go ahead and display my user coming back out, and we see that it will have real stuff in it. If I go, it's probably still out here from the last time I ran it. Yeah, so here's users, first name, last name. You know, it's printing out all sorts of information. This was stuff read back in from Firebase, put back into user objects, and then I called my display method to show that. That makes some sense? So that's writing two objects to Firebase. That's reading objects back out of Firebase. And then what you do with those objects is up to you. Now, what's kind of cool about this guy's still running right now. So I'll just leave it running here. I'm just going to go into Firebase. This is that example from earlier. I'm going to change this person's first name to first name 100. And I'll press enter there. Database just changed. Inside the users folder, I have a listener set up that says I care when something changes inside the users folder. So back out here, this just read in some new stuff. And if I just do a search for first name 100, there's this brand new thing that I know I just added. Right? So I didn't have to run the program again. It was automatically pushed to my Android app. Now, the one thing to keep in mind with the sample code, and it's actually the way I prefer to use Firebase, although it's probably not the most efficient way of writing an app, but I think it's going to play well for a hackathon, is every single time your data changes, it gives you a dump of the entire folder. All right? So when I made a change to that one, for 100 there, it re-gave me all 10 of the users. All right? Which means that if I have like a table view or something like that that's showing my current users, whenever this updates, I can just empty everything out of that table view and then rebuild it with everything it gave me here. Rather than, because you can set up a child listener and say, I only want to know about the one child that changed. And it'll send you that information. Then you got to go look it up in your data set and say, okay, well, this is the guy that changed. So I'm going to go and update that value to this. And then I'm going to tell the table view to reload itself so it has the new data in there. It's probably more efficient because you're moving less data back and forth over the network. But the logic is harder to work with. And you can't just say, everything I used to have is now useless. Throw it out the window, reload the new data. Perfect. Okay, what they don't see doesn't matter. In the real world, probably. But for a 12-hour hackathon, this will work out pretty well. All right, questions about any of this stuff? Everybody have a pretty good idea how this is going to work for the hackathon? I think several of you are on mobile teams in here, so several of you are team leads for those mobile teams. So hopefully this gives you enough to not have to spend a whole lot of time ramping up with talking to Firebase. You can focus on your idea. The big important piece of this was that very first part when you went to tools and set up your connection with your app to Firebase. The second big important piece is make sure you set Firebase up to be public. All right. And then if there's a third most important piece, it's any object you want to be able to store in Firebase, make sure you give that dude public fields. All the fields have to be public. If I make one of these private, it won't compile anymore. It'll yell at me. And also make sure you give it an empty constructor. Then it should be smooth sailing in terms of talking to Firebase. Sound good? All right, so I'll see most of you tomorrow morning at 8 a.m. There will be breakfast, lunch, dinner, and snacks and coffee and crap throughout the day. I don't know what Professor Locklear is bringing for breakfast, but if you hate the food, I had nothing to do with it. If you love the food, I probably still had nothing to do with it. So I have no idea what he's bringing. I'm in charge of coffee, so there'll be good coffee. Lots of Keurigs set up. All right. I will see most of you tomorrow. I'll see the rest of you on Monday.